Scriabin kites and tritone mapping in the Opus 74 Preludes. There's a PDF supplement that you'll see linked below this video that contains the score to the piece that we're talking about and a few charts that I'm going to be referencing. So in front of you here, and on the supplement, is the score to Scriabin's Opus 74 No. 5, the last piece from Scriabin's last opus. As notated here and on the supplement, from a motivic and phrase structure standpoint, the piece is one big Chopin-esque compound period, dividing into two sentential sub-phrases, an antecedent that runs measures 1 through 8, and then a consequent, measures 9 through 17. And while the consequent phrase mostly repeats the first phrase's material, measures 11 through 16 transpose measures 3 through 8 up 6 semitones. So on this first hearing here, please note this overall division and then the T6 transformation. Also pay special attention to the prelude's ending, as I will be contemplating whether it represents a return to or departure from the work's opening harmonic area. So now let's listen to this whole piece. Scriabin's self-professed goal in his late compositions was always to cause a, quote, annihilation of the world in a fiery ecstasy. And in order to do this, he needed to tap into the depths of nature and of reality, something which required constant experimentation with his musical language, as well as deepening his understanding of Theosophy, the turn-of-the-century New Age movement that unified philosophy, religion, and science. In trying to find a way that music might articulate the theosophic mysteries of the universe, Scriabin claimed that his new harmonies are, quote, drawn from nature as if they had existed before, and that they are, quote, bridges between harmony and geometry, unquote. My project seeks to represent and reproduce the mystical meanings that Scriabin tried to embed within his theosophically inspired works. And by proxy, this paper interrogates the relationship between the two phrases of Opus 74 No. 5 and suggests a meaningful reading of the piece's final cadence. To do this, I argue for the deep importance of sets made of two tritones within Opus 74, and mapped these sets using new analytical options offered by recent music geometry research, specifically the notion of quotient spaces. To add interpretive weight to these spatializations, I look for correlations between my analysis and Theosophy, suggesting that Scriabin's compositional choices might gain meaning by viewing them through the lens of the composer's belief system. I will propose connections between the properties of tritones and Theosophy's concerns with symmetry, geometry, specifically the triangle, numerology, specifically the numbers 3 and 6, and spiritual development. Together, these pathways converge upon a theosophically meaningful geometric representation of this prelude. Now, Opus 74 No. 5 contains a lot of tritones. More than 70% of the pitches of Prelude 5 occur within the same beat as their tritone partner. Various commentators have noticed this music's apparent obsession with tritones. Even the composer himself wrote about his late style saying, quote, now I have an entirely different system. Polarity no longer exists between dominant and tonic, but rather between chords separated by a diminished fifth. Additionally, analysts that focus on Scriabin's pitch collections implicitly emphasize the work's tritone content. Cliff Callender analyzes Scriabin's late works by showing the composer's parsimonious voice leading between the octatonic, acoustic, whole tone, and mystic chord collection. And notably, each of these collections is very tritone heavy, suggesting that Scriabin's tritones are not only numerous, but also evenly distributed. Indeed, with the exception of only 2 bars in the 4th prelude, the pitch content of every measure of every prelude within this opus contains at least 1 tritone. More recently, Anna Galboy has extensively analyzed Theosophy's influence on Scriabin's tritone obsession. Her analysis shows the theosophic importance of a unique characteristic of the tritone, a characteristic I'll refer to as the invariance property, where both pitches of a tritone remain invariant when transposed by its own interval. So, for instance, adding 6 semitones to the set 06 will return the same set, 06. And this invariance is, naturally, unique to tritones. Connecting this property to Theosophy, Galboy writes, quote, "Tritones and large-scale tritone transposition invite us to understand something essential about the mystical nature of polarity in Scriabin's worldview. Opposites are complementary aspects of one and the same thing. Polarity is not mere duality, but also unity." So in sum, Scriabin's tritones are both connected to his theosophical belief system and are ubiquitously present in the music. Since they represent a constant presence undergirding his complex non-tonal harmonies, reducing the music to its tritone subsets both follows a musical common denominator and highlights an interval with strong theosophic connections. So here, and on the chart within the supplement, I show all the tritones present in Prelude 5. Each partitioned column represents a measure divided up into its 3 beats. Tritone hunters in the audience will notice that I sometimes follow Scriabin's phrasing divisions rather than the strict beat divisions when parsing the measure's tritones. A vast majority, 41 out of 46 of these combinations, involves exactly 2 tritones. Sets made of 2 tritones, then, provide the object of my analysis, since their logic seems to undergird much of this prelude's harmony. Rick Cohn has investigated the voice leading between 2 tritone tetrachords, with sets of this type constituting a side of his tetrachord tetrahedron. Cohn shows 2 tritones combining to create 3 different set classes. And that's shown here in this figure, which is a reproduction of his figure 4. Now, I add the unison to this list, the 0066, to round out all possible combinations. 2 characteristics emerge from this representation and could be considered as facets of the invariance property. First, the tritone side of his tetrahedron is actually half the length of all other sides. The reason for this has to do with 039's symmetric division of the octave, so consider the cycle represented by these sets, in which 06 holds while a second tritone transposes up by half steps. So then 06 holds, and then you have the 2 06s, and then one of them goes up to 17, and then you're at the second tick there, then go down one more, that goes up to 28, and so on, right? Now when you get to set class 0369, the next step would be 04610, which is equivalent to 0268, effectively reflecting the cycle backwards up my slide. And this leads to the second point of interest about this space. It exists in a mod 6 universe. This is an observation first made in Cohn's 1991 work on interval cycles. Because of the space's reflection around 0369, and because notes are always paired with their T6 partner, these sets can be represented by numbers 0 through 5 without losing any information. So that is, 06 can just be labeled 0 with no harm done. 0167 becomes just 01. Now importantly, this all mathematically reinforces Galboy's point about the tritone. 2 items unify into one through the mystical properties of the tritone. 2 symmetrical sides of a line fold over to unify into one space, and the 2 halves of a modulo 12 universe collapse into a modulo 6 space. Now, in the supplement and right here, in the second to last row, right there, I've labeled the set classes of each set using two tritones from this mod 6 nomenclature, such that 02 represents the French 6th set, what would be 0628, right, becomes 02. There's also a translation key on the supplement that's going to show what each of these sets corresponds with. So what is a French 6, what's a diminished 7th, that kind of thing. The set classes exhibit a certain macrostructure of the Prelude's phrases, showing their similarity. Since measures 11 to 16 and a half or so transpose measures 3 through 8 up a tritone, the set classes remain invariant. Comparing the two phrases' set class rows show that both phrases begin with 5 measures of set class 02, the French 6th, after which set class 01, two tritones a half step apart, enter the mix in bars 6 and 14. So if you look at the handout, measures 1 through 5 and measures 9 through 13 all have that 02 associated with them, the French 6. Then when we get to measure 6 and measure 14, we suddenly change to a 01 set class. There's two tritones, one half step apart. Set class 03, which is the diminished 7th, or two tritones a minor third apart, replaces 02 within the set class palette by bars 7 and 15. So if you look at the table here, measure 7, measure 15 have 03s in them, the first time that we get those. The ends of the phrase then explode into 4 tritone manifestations of the octatonic collection, with phrase 1 receding back to set class 03 and phrase 2 closing off on a single tritone. Now, while Cohn's space shows the tritone's peculiar modulo 6 property, it does not show the pitch invariance between the two phrases, which is perhaps the most mystical facet of the tritone's invariance property. To admit pitch information into the musical geometry, I expand Cohn's two tritone line using techniques present in Callender, Quinn, and Tomasco's generalized voice leading spaces from 2008. These authors define 5 sorts of equivalencies that may be used to cull a set from a musical surface: octave, permutational, transpositional, inversional, and cardinal equivalence. So of course octave means that every C on the keyboard is the same thing. Permutation means that it doesn't matter what order things are in. Transposition means that, so when we're talking about a set class, it doesn't matter whether that set class starts on C or that set class starts on E flat. Like a diminished 7th is the same thing whether it occurs on C or C sharp, right? Inversional, that is when a dominant 7th is the same thing as a half diminished 7th, because the intervals, if you count up, are the same as the intervals if you count down. And then cardinality is how many of each things that you've got. So a diminished 7th starting on C with 5 Cs is the same thing as a diminished 7th that only doubles that C once. Throughout this paper, I'm going to assume octave and cardinal equivalence. Cohn's space additionally assumes transpositional, and inversional, and also permutational equivalence. Now, to represent Scriabin's pitches, I remove transpositional equivalence. So this means that pitch classes are going to be different. This operation expands each set class of Cohn's line into its different manifestations in chromatic pitch space. The 3 diminished 7ths, which here are colored in green, sit at the center of this tritone tone nets, with each set orbited by half-step related French 6ths, and they are in blue. So, for instance, 1-7-4-10 there holds tritone 1-7 and moves the other up by half step, which would go northeast into node 1-7-5-11. While they are labeled here using mod 12 notation, these sets can be more efficiently labeled using modulo 6 notation, as we've already stated. A node like 17410 then just becomes 1,4, implying the tritone pairs associated with them. The smaller sets can then fill out successive layers of this space. With set class 0,1, or in other words, 2 tritones a half step apart, those are all colored orange, and then set classes 0,0, or 2 tritones at the unison, colored violet. So each color is the same set class, and then each instantiation of that color are different transpositional positions of that set class. So 1,4 would be C sharp, E, and then their tritone partners, G and B flat. And then 2,5 would be that up, transposed up 1/2 step. So I admit that this nomenclature takes a little getting used to. However, reckoning from the smallest distance between numbers in mod 6 space will just remind you of the set classes that we're talking about. So the difference between 3 and 4 is going to be set class 1. So if you have transpositionally in an unequivalent class 3,4, it's set class 0,1. If you had 1 and 5, the set class is going to be 0,2 because the distance is not 4 there, but 2. So you're only going to have 4 set classes, 0, 0, 0, 1, 0, 2, 0, 3, and then all the different ways that you can combine the numbers 0 through 6 in order to get those distances. That means if you have 0,4, it's actually an 0,2, 0,5 is actually 0,1, 0,6 is actually 0, 0. So let's talk about the cycles and equivalence classes present in this space. The space is organized vertically by index number, so that means that they all add up to the same number in mod 6 notation. So where that sort of light green arrow is going up, you add any of that up, any of those 2 numbers up, and you get 0 mod 6. So 0 plus 0 is 0, 1 plus 5 is 6, mod 6 is 0. Horizontally are by also the same set class, which is why they're all the same color. And then diagonally by 2 parsimonious voice leading cycles, each of which transposes its respective set members up by half step. So for instance, the cycle on the left side there, which I've noted in green, holds the 1, and then if we start on the bottom left, that 4 goes up by half step to 5, that 5 goes up by half step to 0, that 0 goes up by half step to 1, and that gives us 1, 4, 1, 5, 0, 1, 1, 1 in that cycle. Each cycle connects the upper right-hand edges to the lower left edge, something that becomes clear if we extend this tone that's one more set to the right. The additions mirror the left side of the tone nets. So in other words, each pair of set class rows constitute one continuous transposition cycle, bumping up the set class members by half step as they move to the right. So for instance, 0, 5 bumps up to 0, 1, then to 0, 2, or sorry, then to 1, 2, then to 2, 3, and so on. And these interweaving cycles find their natural form on the Mobius strip, like this. And we can see the topography of a Mobius strip. So consider this side of the strip. Bookending this view are the half-step related diminished sevenths, the sets 0, 3, and 2, 5. Other sets that share the same side also share the same index numbers. So, on the far left there, 2, 5 adds up to 7, which is 1 mod 6, just like the other members there in the vertical line there. The sets situated on the middle side represent changes of 1/2 step from the outer edges. And throughout the shape, each diagonal line represents a transformation of parsimony's voice leading. Now I like to call this shape the 6-pointed tritone kite. I find the moniker catchy, and it sort of captures what an awesome kite this would make. I am, however, not using the word kite in the formal geometric sense of the term. Since it uses actual pitches, the Scriabin kite can map the Prelude's travels through particular instantiations of Combs' set classes, with the Mobius strip living most comfortably in 3D animation and aero leisure. I smash the kite into a heuristic, easy-to-work-with flat space that loses the least bit of information possible, captures the cyclicality of the space, and highlights notable characteristics of the geometry. I represent the members of each set class as points around a hexagon, putting set classes of smaller intervals in the middle and larger on the edges. So at the center, there's 2 concentric hexagons here, representing the members of set class 0, 0, and 0, 1. So that inside dotted hexagon are all of the instantiations of set class 0, 0, or 2 tritones that are in unison. Then, if you go out to the outer dotted hexagon, you have all of the instantiations of set class 0, 0, or sets where there's a tritone 1/2 step apart. And these 2 hexagons are connected with the 12 possible parsimonious voice-leading pathways between them, spatialized here as a 12-pointed star connecting the 2 hexagons. Now, if we go 1 more hexagon outward, we would add the French sixths, or a set class 0, 2, 2 tritones a whole step apart. I color the pathways leading to the even and the odd French sixths, or the French sixths that occupy the even and odd whole tone collections, in 2 different hues of blue, showing the symmetric divisions of space. Adding 1 more hexagon with 12 more half-step transformations captures the voice leading between members of set class 0, 2 and 0, 3, or the fully diminished sevenths, the 2 tritones a minor third apart. Now, however, because the diminished seventh symmetrically divides the space, you recall that there are only 3 members of this set. So each point of the hexagon is identical to the opposite point. So if you look in the sort of upper rightish corner, you'll have a yellow 1, 4, and then down at the bottom of the figure you have a red 1, 4, and these are the same chord, the same spot. So this should be a triangle, but instead I'm representing it as a hexagon so that I can get each of the voice leading pathways shown. But if you occupy 1, 1, 4, you're actually occupying both spaces at the same time. So this set class, because of its symmetry, conflates the 6 points of a hexagon onto the 3 points of a triangle. In sum, members of 2 tritone set classes can be represented as concentric hexagons connected to each other by 12-sided 6-pointed stars that represent the parsimonious voice leading between the sets. Now in this animation here, I showed the Prelude's movement on the tritone kite, with bands of set classes highlighted for clarity. So recall that the inside layer is set class 0, 0, then followed by 0, 1, 0, 2, the French sixths, 0, 3, the fully diminished sevenths, concentrically. Now if you're watching with the score, with the supplementary material, this is a good time to take it out and read along. Because this representation here elegantly shows the subdued symmetries of measures 1 through 5, as it restricts itself to sonorities using only odd French sixths, moving along the kite's violet triangular points. and orally this is going to capture a whole tony feel present in the beginning of the phrase. But then this balance unsettles in measure 6 as it admits new set classes into the musical palette. This is going to begin to sound less whole tony and more crunchy octatonic-y. Then I show the octatonic explosion by highlighting the nodes of each combination of the 4 tritones, finally receding to a single node at the end of bar 8. So now let's listen with animation. This representation captures something about the mystical properties of tritone invariance, even after admitting pitches into the geometry, that is, relaxing transpositional equivalence. The first and second phrases still occupy identical pathways onto the space, because, as previously discussed, the consequent phrase retraces the steps of the antecedent. After initial 2 measures of at-pitch repetition, bars 11 through 16 transpose the materials up a tritone, preserving not only the set classes, but the pitch classes themselves. The only variation comes in the last moments of the prelude. The last beat of bar 16 adds a tritone to the material of bar 8, and the phrase ends sounding a single tritone. This animation traces these transformations. Let's listen to the prelude's consequent phrase with animation. So again, this shows the mystical properties of tritone invariance, since it shows how, even though we've admitted pitches, the first and second phrases occupy the same space, but the same pathway on this figure. Now, this geometry also begins to shed meaning onto the prelude's ending. By ending on tritone 1, Scriabin emphasizes the most prevalent element of the prelude. 37% of the prelude's tritones are tritone 1, getting the most stage time by a solid 10%. In this sense, one imagines this actor slowly emerging as the main character of the prelude's drama, a role confirmed by his solitary presence at the closing curtain. Now, alternatively, one might interpret the ending as a return to a home tonic. Now, after all, the horizontal interval that affects the ending in this kind of cadence-like way articulates tritone 3, tritone 1's pair from both phrases' beginnings. And incidentally, and there's the cadence-like figure, incidentally, tritone 3 is the second most populous tritone of the prelude, weighing in at 27%. That is, if the final pseudo-cadential fall participates in the harmony, then the prelude ends where it began, using a 1-3 tritone set. This ambiguity, which I represent on the supplement by surrounding the final 3-9 tritone with parentheses, certainly coheres with the theosophic value of the tritone. By using vague pitch and chord syntax, the ending mixes departure with return, change with stasis, unity, and duality, and we will return to this idea later. But there are more geometric representations of ambiguity to be unearthed. By considering permutational equivalence, the six-pointed kite highlights the similarity between measures 3 through 8 and 11 through 16. So recall that permutation was when we didn't consider the order of things to matter. But by considering this parameter not equivalent, the resulting geometry finds differences between the patterns. So compare measures 3 and measures 11 that are on this slide in front of you. The right hand begins measure 3 by playing ordered PCs 11, 9, 5, 3. Measure 11 swaps each PC for its tritone pair, resulting in 5, 3, 11, 9, the same pitches in a different order. Now, if we have permutational equivalents, these of course are the same thing, but relaxing permutational equivalence expands each node on the 6-pointed tritone kite to 8 different nodes, distinguishing between every different possible tritone ordering. So, 3, 9, 5, 11, which was what each of those measures has in it, becomes all sorts of different orderings of those things. They're all different. So with that one node on the permutationally equivalent tritone kite would become 8 different points in space. The 6-pointed kite now becomes twice as long, now living in true mod 12, not mod 6 space. So imagine so if it's twice as long, imagine a cycle that increased a tritone by a half step. So you've got 0, 6, 1, 7, and that 1, 7 goes to 2, 8, then to 5, 11, 6, 0, and so on, and so on, and so on. Now, in the 6-pointed kite, after 5, 11, you would find yourself back at 0, 6. But when permutation matters, your cycle continues to 6, 0, right? So 5, 11 up 1 tick doesn't go to 0, 6, it goes to 6, 0. And therefore it's going to take you twice as long to get to the cycle starting point. Now, also because the space differentiates between permutations of set class 0, 0, the single side of the Mobius strip is going to unfold into 2 sides. So since 0, 6, 0, 6 does not equal 0, 6, 6, 0, that one side is going to unfold into something that's twice as long. Now furthermore, the whole unfolded Mobius strip sprouts a double. There's going to be 2 doppelganger Mobius strips that are going to fuse together. The strip in which 0617 exists now has a doppelganger in which 1706 exists. So there's going to be this flip inversional strip. The resulting shape will be a 12-pointed torus. Now, here I show the 2 doppelganger Mobius, the 2 double-length Mobius strips, the 2 doppelganger double-length Mobius strips, combining to make the torus. Notice how set class 03 sits in the middle of the gray strip, just as it sat in the middle of the 6-pointed kite. Then there's this other seam, which is 0, 0, which sits in the middle of the white strip. And what we've got is a yellow and a purple side that are the 2 doppelganger strips, with 0, 0 sort of being this looking glass between the 2 doppelganger kites. In this space, a node is maximally distant from its tritone transposition. In the next animation here, I show that node 11593 exists maximally distant from its tritone transposition, 51139, sitting 12 whole transformations away. So far from showing a return to earlier material, the 12-pointed torus would map the second phrase as maximally distant from the first phrase. We could imagine 2 equal pathways, like those that were mapped on the 6-pointed kite, occurring on complementary doppelganger Mobius strips, resulting in maximally distant pas de deux between the 2 T6 related phrases, a dance made more bizarre by their completely identical pitch content. Now, other quotients of this space capture other facets of this music. So quotients are when you take a single space and then you apply some sort of transformation on it, like you say that things are not permutationally equivalent anymore, and then that space changes into some either larger or smaller space. Consider a set with 2 tritones, A and B, made up of pitches X and Y. if we regarded the order of A and B as permutationally equivalent, but continued to regard X and Y as permutationally distinct, we would have a situation in which 5, 11, 3, 9 would equal 3, 9, 5, 11, but would not equal 11, 5, 3, 9. So the outside order doesn't matter, but the inside order does matter. This choice would fold the 12-pointed torus in half, mapping the two toruses' constituent Mobius strips together. So here I've taken away that sort of purple fuchsia-ish Mobius strip. That dismantles into just one long strip. Now if you tighten this and flatten it out, the geometry results in this 12-pointed kite. A quotient-related tritone geometry twice the size of the original 6-pointed kite and half the size of the 12-pointed torus. Side by side, the 12-pointed kite is clearly twice as long and contains twice the number of transformations between each side. The new space captures the Prelude's T6 relationship in yet another way. In this space, each tritone transposition maps a set onto its mirror image on the flip side of the 12-pointed kite. So for instance, the blue-colored 0617 there exists as the mirror image of its T6 partner, 6071, as indeed all sets mirror their T6 permutations around the central axis. So it just basically flips it over when you do a T6 transformation. Awesomely, the palindromic sets like 3993 exist at the center of the shape, since they're their own permutation. The pas de deux between Prelude 5's two phrases steps between the vertically opposite sides of the kite. The second phrase answers the first by flipping the kite. Theosophic mystery viscously drips from these shapes. The symmetrical pas de deux of the 12-pointed spaces shows the two phrases as being opposites, while the 6-pointed kite unifies the phrases. In the same musical utterance, Scriabin embeds the theosophic mystery of unity in duality and identity in opposition. Furthermore, these related geometries show the Prelude's ending blurring these ideas even further. Measure 1 contains the ordered set 3917, while the very last measure, including the pseudo-cadential interval, contains the set 9317. Unlike the complete T6 transformations of the previous measures, this measure holds one tritone and flips the other. Both 12-pointed spaces show the transformation as taking 6 moves, the maximum that one can travel while still retaining one member of the set. On the 12-pointed torus, the node moves from the outside of the torus to the inside. On the 12-pointed kite, the 6 moves rotate around the shape rather than flipping the kite over. In contrast, when considered on the 6-pointed objects, the end is a return to the beginning. Here, the 6 total parsimonious transformations sum to an identity operation. If the complete tritone transposition that occurs between phrases blurs the line between duality and unity, the final cadence blurs the blurring. Aspects of change alloy with ingredients of stasis, creating a subtle melange of returning and departing, of preservation and of change. Outside of capturing the connection of unity and duality, my geometries exhibit other potentials for theosophic interpretation. Seeing as Scriabin felt that his new language relying on diminished fifths utilized universal, mystical, and geometric natural laws, I end my paper by suggesting possible further theosophic meaning found within my tritone spaces. Now, before we go on to delve into further theosophic potential meanings, let's take a moment to acknowledge and address some of the complications that accompany connecting geometry with musical meaning. This type of analysis is very different than finding meaning within sonata form deformations by Beethoven or within harmonic novelties in Liszt. After all, I am imposing mathematical formalizations onto Scriabin's music that the composer never could have possibly known about. How can I possibly get away with this? I find that these geometries are viable interpretive devices for two main reasons. The first is composer-centric, and then the second is listener-centric. First, the composer-centric one. While Scriabin certainly did not have explicit knowledge of these ideas, that doesn't mean that they don't articulate Scriabin's partial or implicit knowledge. That is, as our theosophic discussions have and will show, Scriabin was very interested in the symmetry and transpositional identity available to certain pitch classes, and the mathematical properties discussed in this study formally described these characteristics. You could sort of imagine Scriabin sitting down at the piano and toying with taking some pitch class set and then moving it up a tritone and seeing what changes, what's different, and then thinking about the theosophic implications about that. And my claim is that the geometries capture something about that process. Now second, Scriabin's music, and this is the listener-centric one, because of its experimentation and para-religious context, begs the listener to find deeper meaning within it. It's well documented that Scriabin would constantly boast about the deep meaning embedded within his music, but then he'd remain silent as to what actually comprised that meaning. His bold but deliberate musical experimentation invites listeners to make equally bold and deliberate readings of the pieces. Almost unique in the Western musical tradition, Scriabin's music presents vast Rorschach blots, inside which we, as listeners, are invited to find spiritual and theosophic meaning. So now back to the business of boldly and deliberately unearthing this theosophic meaning. First, my geometry recontextualizes old tonal structures in new ways, and this would be a very attractive idea for Theosophists. Scriabin believed that, in the course of the universe, different planes of reality would emerge from one another, revealing sequentially more enlightened and pure states of being. Now this slide shows a figure from the imagination of Helen Blavatsky, the mother of Theosophy, representing the sequential and evolving astral planes. If Scriabin was developing a more perfect musical language that would affect an evolution of reality, it seems reasonable that he would look for natural geometries and laws embedded within the present musical language, liberating tritones, diminished sevenths, French sixths from their earthly bondage within the mundanity of the tonal system, and elevating them to a more natural or lawful geometry would be very theosophically appealing. My geometries, then, show the evolutionary potential present within chromatic pitch space that Scriabin was tapping into within this opus. So furthermore, a theosophist like Scriabin would be very attracted to the numbers and geometric spatializations embedded in tritone harmonies. The number 6, especially when divided into two triangular groups of 3, was especially powerful to the theosophic worldview. Blavatsky called the triangle, quote, the first geometrical figure, which represents the synthesis of unity and duality. 3 is, after all, the sum of 1, unity, and 2, duality, and that is, in full disclosure, Blavatsky's own reasoning. A 6-pointed star made of 2 conjoined triangles embodies deep universal forces to Theosophists, representing various concepts like the 6 forces of nature and the 6 divisions of the human soul. So here I show typical doodles from contemporary theosophic texts combining 2 triangles into 6-pointed stars. Of all the chromatic intervals, the numbers 3 and 6 occur with greatest significance in tritone-based geometries, popping up from enumerations as disparate as interval size, the tritone 6 half steps, to set class cardinalities. Each set has either 3 or 6 members. Placing these doodles next to my 2-dimensional representation of the 6-pointed kite highlights my space's analogy with theosophic concerns. Now, on the one hand, the visual similitude is complete happenstance. As I said before, I'm certainly not suggesting that Scriabin realized that tritone voice leading could be mapped with the same two interwoven triangles as the duals of the human soul. Now, on the other hand, the motivations that cause someone to theorize the human soul in such a manner are the same as the motivations that cause a composer to saturate his music with tritones. So again, you can imagine Scriabin at the piano playing a fully diminished chord, counting up the 6 tritones in that, the 6 semitones in that tritone, and then there's 3 between the minor third, and then thinking that there are 2 interlocking 6s and 3s going on there, and being intrigued with the potential theosophic connections. And that doesn't mean that he's, seeing these explicit triangles coming out, but sort of realizing that there's a bunch of 6 and a bunch of 3 going on in this tritone space. In different ways, both of these pictures here potentially captivated Scriabin and influenced his compositions, the left explicitly and the right implicitly. By connecting geometries of 2 tritone sets to theosophic concerns, my analysis offers a venue to reinvest theosophic mystery in Scriabin's harmony and voice leading. Now, thank you all for listening. Feel free to contact me at christopher.w.white@yale.edu if you have any questions or concerns or interests in this work. Again, thanks a lot for listening.